Okay, how about here's a closed interval. Right, with trig functions, we want to be on a closed interval because they're repetitive. They keep repeating. There'd be an infinite amount of extreme. So we'll do it on a closed interval. Try to figure out the absolute maximum, absolute minimum of 2 sine of x minus cosine of x from 0 to 2 pi. You want to figure out where's the first derivative 0 or undefined. You get our critical numbers. Test those numbers as well as the endpoints of the interval. Right, so when we figure out our numbers we want to test, I already know I need to check at 0 and 2 pi. Right, maybe instead of writing 0, 2 pi, I'll do the points. So let's check. When x is 0, what's the value of this function? Sine of 0 is 0. Cosine of 0 is 1, so that would make it negative 1. So at 0, it's at negative 1. How about at 2 pi? Sine of 2 pi is 0. What's the cosine of 4 pi?
It's still negative 1, right?
Yeah, still, cosine of 4 pi is 0, so that's still negative 1. Right, just think about it. If you were on here, right, we have a circle. Here's 0, pi over 2, pi, whoops, 3 pi over 2.
Couldn't it still go higher or lower than those
Oh yeah,
values on the interval?
yeah. We just have to check those, right?
Those are just the starting point?
Yeah. And so this would be 2 pi or 4 pi over 2, then 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, which is 2 pi. Yeah. So those are our endpoints. Those could be maximums or minimums, right? They may not be. Then what we got to do is take the first derivative. Figure out where that is 0 or undefined. So the derivative of 2 sine is 2 cosine. What's the derivative of cosine of 2x?
It's a negative sine 2x times 2.
Yeah, negative sine of 2x times 2. 2 negatives would make a positive, so we get positive 2 sine of 2x. Or we had to do the chain rule. Derivative of cosine is negative sine. That made a positive sine. The derivative of 2x is 2, so we multiply by 2. So cosine and sine are always continuous. They're never undefined. So now we just have to figure out where does that equal 0. So without a calculator, right here we're going to have to remember our double angle identity.
I think that would opposite.
What is sine of twice an angle?
2
2
sine
sine
theta
of
cosine.
x.
2 sine of the angle cosine of the angle. All right, so let's see. If we're going to solve this, there's a cosine in both of these, isn't there? We can factor out a cosine, maybe even a 2 cosine.
Terry said factor out the 2.
Factor out a 2
So it's like,
and a cosine. So if we do that, we're left with a 1 here. Then over here, we're left with plus 2 sine of x. All right, so for 2 cosine to equal 0, cosine would have to be 0.
And is
And then-
2 sine of x equal to like cosine squared of x or something like that?
Wait, 1 plus 2 sine, 1 plus 1 minus cosine squared is sine squared, but 1 plus 2 sine would set that equal to 0.
it's sine of.
Yeah, we wanted, that means we want to know where does sine equal negative 1/2. So cosine is 0. Well, we can go back to this right here, huh? Cosine 0, we go straight up and straight down. Pi over 2 and 3 pi over 2.
I say at
Middle and
45.
pi over 4.
But Terry, we're sticking with
Negative.
radius. And this sort of clues us in too. We want to be between 0 and 2 pi. 45 degrees is in
I
between.
mean, yeah.
Yeah, so where does sine equal negative 1/2? Jocelyn, people could memorize the unit circle, right? Or they could think to themselves, hey, if advanced students take calculus, sine is negative down here, right? The bottom two quadrants. Or think to yourself, sine is up and down. Whenever you go down, sine is negative. So it's in these two quadrants, and then if they remember their friend, the 30, 60, 90 triangle, that goes square root of 3, 2, 1. Right? Sine of 1/2, if we're thinking degrees, it'd be 30 degrees, right? So 30 degrees in this quadrant here would be 180 plus 30 would be 210. So I would maybe at first think in degrees, it'd be 210. In this quadrant, it would be 30 short of 360, it'd be 330. So in radians, if you multiply 210 by pi over 180, right? Or think whenever you're 30, it's, I heard somebody say over 6. Right, it's over 6. 30 goes into 210 7 times, into 180 6 times. 30 goes into 330 11 times. Oops. And 180 6 times. Right, so you're just thinking when your reference angle is 30, it should be over 6 because 180 divided by 30 is 6. And then you just figure out how many times 30 goes into these to get the numbers. Wow, so we've got 4 critical numbers that we need to test. So whenever we do that, let's see, we'll come back to this. We'll move these over a little bit. We also need to check now when x is pi over 2. Right, so if we plug pi over 2 in here, the side of pi over 2 is 1. And actually, you know what, maybe it'd be better.
Wait, are we checking pi over 2 because it's one of our solutions down there? Or?
Yeah, well that's what we found these. These are our critical numbers, right?
So cosine of pi.
These are our critical numbers. If we're just looking for extrema, these are places where the first derivative is 0. So those are places where the graph probably changes direction.
So we're going to plug them in to find the y values to determine where they are.
Yeah. We're going to plug them in to find the y values to see if they're maximums or minimums. All right, so you always go back to the original function. So maybe I better write this down here because now to make a careless mistake if I try to do it in my head. So we've got 2 sine of x minus cosine of 2x.
Yeah.
All right, so if we figure out the value of the function at pi over 2. All right, we're going to get 2 times pi over sine of pi over 2. Sine of pi over 2 is 1. 2 times 1 is 2. Minus, put pi over 2 in here, you get cosine of pi. What's the cosine of pi? Negative 1, that makes it positive 1. 2 plus 1 is 3. Right, so that's got potential to be our maximum. Right, pi over 2 and 3. So when x is pi over 2, the y is 3. We also want to check 3 pi over 2. So we come back to this again. Let's find the value of the function at 3 pi over 2. What's the sine of 3 pi over 2? Negative 1 times 2 makes it negative 2. Put 3 pi over 2 in here, you get the cosine of 3 pi. Cosine of 3 pi is over here, right? 0, pi, 2 pi, 3 pi. What? There are cosines left and right, right? If I would have put the points on here, this has got a point here at 1, 0. This up here is 0, 1. This is just assuming we have a circle of radius 1. This point over here is negative 1, 0. And this point is 0, negative 1. If you think of any point on there, the x is cosine and the y is sine. How to say it? The x is cosine, the y is sine. So cosine of 3 pi is negative 1. So that would make it a positive 1. Negative 2 plus 1 is negative 1. All right, so again, we put 3 pi over 2 in here. Sine of 3 pi over 2 is -1 times 2 is -2. Put 3 pi over 2 in here, you get cosine of 3 pi is -1. That makes a positive 1. So that sort of ties those other two for possible minimums. But then we also have to check now 7 pi over 6 and 11 pi over 6. So this one had a lot of things. Let's see, 7 pi over 6. So we'd have 2 times the sine of 7 pi over 6. Remember that reference to 30, right? We already knew the sine of 30 was a half, and that quadrant's negative. So it'd be 2 times negative a half. And then if I put 7 pi over 6 in here, we get 2 times that. 2 would go to 6 3 times, so we get 7 pi over 3. 7 pi over 3 would be about 420 degrees. All right, so here's, maybe on the side here, all right, we're doing this. We're doing cosine with 2 times 7 pi over 6. All right, which would give us cosine of 7 pi over 3. All right, and 7 pi over 3, if I convert that to degrees, you multiply that by 180 over pi. The pi's cancel, 3 goes 180, 60 times 7 is 420. Whenever you have an angle bigger than 360, you can subtract 360 from it. So that's the same as 60. So the cosine of 60 is 1/2. So that's just then minus 1/2. So this would be -1 minus a half is -1 1/2. Right, or -3/2. We got a new minimum, don't we? 7 pi over 6 gave us -3/2. Let's try the 11 pi over 6. Find the function at 11 pi over 6. So again, I think the sine of 11 pi over 6 is going to be -1/2. Right, because it's the same thing. It's in, but it's in this quadrant. Sine is negative. Right. Then when we do the cosine, maybe I should just have this here. It's minus. Then we're going to get the cosine. We put 7 pi over 6 in here, or 11 pi over 6. We get 11 pi over 3. If I do the same type of thing that I did here, right? 3 goes 180, 60 times 11 would be 660. Subtract 360, you get 300. This is the same as the cosine of 300. And 300 degrees 1/2 would be here, right? So it'd be 60, it'd be cosine of 60, it's 1/2. And that makes it -1/2, right? So we get -1 minus a half. We get -3/2 again.
Isn't this in positive in that column?
Yeah, but the function was minus cosine, right? So since it was positive, that made it negative. So look at that. These two look like here are our minimums. These are our absolute minimums, right? And this one is our absolute maximum. Yep. If they're the same, you can't say one's smaller than the other one, yeah.
So what is the purpose of that other one? I guess that
This one,
3 pi over 2.
it changes direction there, but it's not a lowest, right? If we check this, if I come in here and the y equals and put 2 sine of x minus cosine of 2x. I'll do my window, I'll just go from 0 to 2 pi. I go from 0 to 2 pi, and then I'll just hit zoom fit. So, because we only wanted to look at it from 0 to 2 pi, so I set the x's and I let the calculator find the y's. So look at that, there's two lowest points here, right, and one highest point. I can go into calculate, I can calc maximum. I don't really want to move this cursor all the way over. Well, I'll tell it to go to 0. And maybe 2 pi is 6 something, so maybe go to the right, I'll just go to 5 instead of 2 pi. It should find this highest point. Yeah, look at it, it's 1.57, which is pi over 2 and 3. And then, what were you saying about these other two?
So that second point that we found where it changes direction is that middle part.
Yeah, that's a relative maximum, but not, since we're on a closed interval, there's only one absolute maximum.
Okay.
But anywhere the first derivative is 0, the function should be changing direction, right? Because you have a horizontal tangent.